Muscular tissue is the third type of tissue we're going to be discussing here. And there's really three different types that we're going to care about. And to be honest, you're going to be seeing a lot about these different types of muscles over and over and over again. You're going to be talking about skeletal muscle and all these different muscles in A&P2. You're going to be discussing cardiac muscle in more greater detail in A&P3. You're also going to be discussing smooth muscle in a lot more detail in A&P4. So you might as well just get comfy cozy with this next bit of information because it's going to be foundational. It's going to be good for you for this other A&P2, 3, and 4. A lot about what they do and help out with, they can help. The skeletal muscle has a lot to do with maintaining posture, producing heat, and giving you motion, while cardiac muscle has help pushing blood around, and smooth muscle is there to help move things along and constrict or dilate depending on where you are. Skeletal muscle, here that it's cardiac muscle and smooth muscle are all put together right here. You can see that they're being compared. You can take a look, see at all three different ones. Let's point out a couple of the main differences that we see here, but let's include this little chart here to help us make certain we hit every single bit and piece that we need to talk about. First off, skeletal, you can take a stab in the dark. You know where it's attached to. It's attached to the skeleton. It's the one that's responsible for movement. It's the one responsible for lifting things as well as really keeping you warm when you shiver. Question is, voluntary. Do you have control over it? Can you say, hey, skeletal muscle, stop moving. Hey, skeletal muscle, move. And it does it? In a normal individual, yes. But what about cardiac? Cardiac means heart. Cardiac means heart. Can you tell your heart, hey, heart, stop beating? No. That's something you don't really have control over. And then smooth. Can you tell your smooth muscles, hey, stop making gurgling noises, stomach. You're embarrassing me. No, you can't really do that. You're doomed to gurgle. Striated. Let's take a look at what striated means. Striated means is they're little itty bitty bands that you can see on the muscle. I'm going to go ahead and zoom in a little bit. I'm going to exit out the presentation. I'm going to zoom in. Something tells me I want to click that. Zoom in a good 200% onto that skeletal muscle and that cardiac muscle. These striations are actually the functioning unit of the skeletal muscle, as well as if you take a nice close look, you can see these little faint stripes going on right here in the cardiac muscle. So yeah, skeletal and cardiac muscle definitely have these striations. Let's take a look at smooth muscle here real quick. No, I don't really see any striations. And if you said that, if you agree with me, then yes. Excellent. I'm glad you didn't see those striations. So yes for skeletal, yes for cardiac, no for smooth. Finally, intercalated discs. If you remember gap junctions, well, gap junctions is the one that sort of connected the cells together and it allows for certain materials to go across the way. Skeletal muscles don't have it. What intercalated discs look like is right there. It's that very heavy, heavy, heavy pink cross section right there. Skeletal muscles is one continuous muscle. It's one continuous cell. While a cardiac muscle is actually a couple of cells hodgepodge together. You don't really, and it's really that dark pink. This is like your characteristic. This is where you need to highlight. This is where the defining moment of what a cardiac muscle is that intercalated disc that stains really, really, really well. So yes, cardiac muscle, and yeah, you can't really see any intercalated discs here for smooth, so no. Next question, do the muscles branch? Do the fibers that are contained within each cell branch off to connect with somewhere else? Skeletal, no, these are just parallel cables of muscle fiber. Cardiac, Well, let's take a look-see. Oh, look at that. And that branches off there, that branches off that way, this one then branches off that. And look at that. This cell branches off kind of weird off to two different cells. Yeah, definitely. Smooth muscle. Well, does a cell merge and branch off? No, not really. Okay. Finally, the number of nuclei per cell. Let's take a look at skeletal. You'll see that skeletal muscles nuclei are really tucked off to the side. It's really, really hard. They don't really have space. So they're just stuck there. And if you remember my little comment earlier, these skeletal muscles really are just like one cell, continuous cell. So what happened is these cells have merged when you're an embryo, merged together, and they've donated their entirety, and their cell membrane have merged together as well. So they are just now one continuous cell. The only thing that's not missing here is the nuclei. They're the remnants of what you had done earlier. These nuclei are just remnants of your old cells. They're all part of one giant cell. So the number of nuclei in the skeletal muscle is multiple. Cardiac, remember that intercalated disc is like the boundary. It's that gap junction between cells. Let's see here. Do we have... I see one nucleus here in this one. I see one here. I see one here. Yeah, it's just one nucleus. And then we got this one. Let's see here. I see one there, one. Yeah, they're all in their own cell. So that's one as well. And if you remember this, if you can just really capture this understanding, you're going to be A-OK for A&P2, A&P3, and A&P4 when we talk about muscle, as well as you're going to be doing great for A&P1.